1. Third interstellar comet discovered. NASA's 3I/Atlas explained. 2. 3I/Atlas. Humanity's third interstellar object arrives. 3. 3I/Atlas live. Watch the new interstellar comet online. 1. Third interstellar comet discovered. NASA's 3I/Atlas explained. Astonishing but true. Humanity has just discovered another interstellar visitor, Comet 3I/Atlas, a rare traveler from beyond our solar system. What does this mean for science, and what controversies could it spark in our understanding of cosmic wanderers? Keep reading to find out. There's more beneath the surface than most people realize. The story begins in early July 2025, when NASA's ATLAS, Asteroid Terrestrial Impact Last Alert System, telescope, stationed in Rio Hurtado, Chile, spotted something peculiar in the sky. This observation was quickly shared with the Minor Planet Center, and more data soon poured in. Astronomers scoured the archives of 3 other ATLAS telescopes scattered across the globe, as well as images from Caltech's Zwicky Transient Facility at California's Palomar Observatory. These earlier, pre-discovery sightings actually dated back to June 14th, meaning the journey of Comet 3I/Atlas had already been under quiet observation. But here's where it gets truly fascinating. Comet 3I/Atlas is only the third interstellar object ever found passing through our solar system, making it an astronomical celebrity. The telltale sign? Its orbit is hyperbolic, not elliptical, which means it's just passing through and isn't captured by the sun's gravity. When scientists traced the path of 3I/Atlas backward, it clearly originated outside our solar system, somewhere in the vast, mysterious space between the stars. Concerned about a collision? Don't worry. This wandering comet poses zero risk to Earth. Even at its closest approach, it will remain about 1.8 astronomical units from us. That's roughly 170 million miles, comfortably farther than Mars. Its nearest brush with the Sun will come around October 30th, 2025, where it'll swing within just 1.4 astronomical units, putting it just inside Mars's orbit. Currently, astronomers worldwide are racing to unlock its secrets, analyzing its size, composition, and how it behaves as it warms up near the Sun. Through September 2025, skywatchers with large telescopes may still catch a glimpse before it's lost in the Sun's glare. Intriguingly, it will emerge on the other side of the Sun by December 2025, providing a fresh chance for study. This will likely reignite debates on whether to prioritize resources for observing such rare cosmic visitors over more predictable solar system bodies. If you're wondering about the name, here's the breakdown. 3I stands for Third Interstellar, while Atlas honors the survey team that made the discovery. The I is key. It marks only the third time astronomers have confirmed an object's origin outside our solar system, following in the footsteps of 1I/Oumuamua, spotted in 2017, and 2I/Borisov, found in 2019. These designations are more than just labels. They signify a revolution in how we find and classify cosmic interlopers. But some astronomers debate if all these objects are truly interstellar. Could we be misclassifying strange solar system bodies? But where did 3I/Atlas come from? The prevailing theory is that this comet formed around another star system before being hurled into interstellar space, possibly by gravitational interactions or a catastrophic event like a close encounter with a giant planet. For millions or even billions of years, it wandered through the void until it finally entered our neighborhood, approaching from the direction of the constellation Sagittarius, near the galactic center of the Milky Way. At the time of its discovery, it was already inside the orbit of Jupiter, about 410 million miles from the Sun. How did astronomers know this comet was not a native of our solar system? It all comes down to its path and speed. 3I/Atlas's velocity is so high that it can't be held by the Sun's gravitational pull. Its hyperbolic trajectory means it will slingshot through and leave, never to return. This is a key detail. Some skeptics argue whether gravity calculations are always precise enough to declare something interstellar. Could future revelations overturn some of these designations? What about its size and nature? While the exact measurements are still under debate, one thing is clear: 3I/Atlas is an active comet. Its icy core is producing a glowing coma, the cloud of gas and dust that forms when such objects heat up near a star, firmly distinguishing it from an inert asteroid. As for its speed, 3I/Atlas is hurtling through space at an astonishing rate, roughly 137,000 miles per hour, about 221,000 kilometers per hour. And as it nears the Sun, it will accelerate even more, making it one of the fastest-moving objects we've ever observed in the solar system. And now for a question guaranteed to stir debate. Should we divert more resources to studying these fleeting, hard-to-predict interstellar visitors, or focus on our own backyard, asteroids and comets that might threaten Earth? What intrigues you more, the mystery of deep space or the practicality of planetary defense? Wherever you stand, one thing is certain. Each new interstellar object challenges our understanding of the universe and invites us all to ask new questions. Do you agree with the current scientific consensus? Or do you see things differently? Share your thoughts. Let's start a cosmic conversation. 2. 3I/Atlas. Humanity's third interstellar object arrives. We are not as alone as we think. Our solar system is a magnet for cosmic wanderers, and the latest visitor is rewriting the rules of astronomy. But here's where it gets controversial. What if these guests from beyond are telling us our cosmic neighborhood isn't as secluded as we once believed? The story of our solar system as we knew it was a local affair until recently. For most of human history, every planet, moon, asteroid, or comet we spotted originated within our own solar system. This changed dramatically in 2017, and now in 2025, the universe is sending us its third mysterious messenger, 3I/Atlas. Picture a cosmic game of pinball, but instead of flippers, gravity is at work. Our solar system's inhabitants, planets, moons, asteroids, and comets, are all governed by Newton's law of gravity. Moving in elliptical paths around the Sun, asteroids and Kuiper belt objects form belts, while some, nudged by gravity, shoot inward from the Oort cloud, brightening as they near the Sun and sometimes producing spectacular tails and debris streams. For thousands of years, this was the full picture, until the discovery of our first interstellar visitor, Oumuamua, in 2017. Oumuamua shattered expectations. This odd, cigar-shaped object was small, about 100 meters, but it moved far too quickly to be from our solar system. Instead, it was our first bona fide interstellar traveler, proof that objects from other star systems could zip right through ours. Not long after, astronomers found Borisov, a much larger, nearly 1 kilometer, object, unmistakably from interstellar space and loaded with ice that erupted into a brilliant comet-like tail. Fast forward to July 2025. Astronomers, scanning the skies for faint, fast-moving objects, spot something extraordinary. Initially labeled A11PL3Z, this object was quickly renamed 3I/Atlas, https://minorplanet center net/mpec/k25/k25n12.html. After being confirmed as another interstellar visitor, this detection is sparking excitement and debate. Just how many of these cosmic nomads are passing through, and what secrets do they carry about the universe beyond our Sun? Let's take a closer look at where these objects come from. Imagine our Sun as the center of a vast, layered bubble. The innermost layer is where the planets live. Next comes the Kuiper belt, followed by the Oort cloud, a spherical shell of icy bodies stretching from thousands to possibly over a light-year away. Most people think our solar system is isolated. After all, the nearest star is over 4 light-years away. But here's the reality. Our galaxy is chaotic and crowded. Not only do stars zip by each other, sometimes passing dangerously close, but countless smaller objects do the same. Some theories suggest our galaxy is filled with planets kicked out of their original star systems by chaotic gravitational tugs, orphan planets, born in the darkness between stars, rocks and ice chunks, ejected from forming solar systems, and the debris of ancient planetary collisions, creating vast swarms of interstellar icebergs. As these objects zoom through space, only two things really affect them: gravity and momentum. Passing through the particle-rich interstellar medium, they're polished and eroded, like jagged rocks smoothed by a river. This isn't just theory. Evidence comes from our own cosmic past. Around 70,000 years ago, Scholz's star, a pair of brown dwarfs, passed through the outer limits of our solar system, stirring up the Oort cloud. This event, invisible to our ancestors' eyes, was just one of many close encounters our solar system has experienced. In fact, such events are expected every few million years for a star like our Sun. But here's the twist. While stars and brown dwarfs are rare, smaller objects like asteroids and comets are incredibly common. Countless billions or trillions likely drift between stars. To find these, astronomers painstakingly photograph the same patches of sky night after night, searching for faint dots of light that move against the starry backdrop. The discovery of 3I/Atlas is a triumph of this detective work. The Atlas telescope in Chile, part of a global network funded by NASA, first spotted this object as it moved rapidly across the sky near Jupiter's orbit. Its speed and trajectory were a dead giveaway. This was no ordinary solar system object. With a speed of about 61 kilometers per second, it was moving too fast to be bound to our Sun. Its path suggested it came from the direction of the galactic plane, an area often overlooked by other surveys. Now let's talk orbits. Normally, objects in our solar system follow circular orbits, eccentricity equals 0. Elliptical orbits, eccentricity between 0 and 1. Parabolic orbits, eccentricity equals 1. Right at the edge of being bound. Hyperbolic orbits, eccentricity 1. Unbound. Most objects in our solar system have eccentricities up to about 1.05. But the 3 interstellar visitors we've detected so far break all the rules. 1. Oumuamua 2017 eccentricity equals 1.199. 2. Borisov 2019 eccentricity equals 3.36. 3. 3I/Atlas 2025 eccentricity equals 6.2. https://arcs4.org/pdf/2507-02757, the highest ever recorded. A diagram shows 3I/Atlas's path as it plunges toward the Sun, making its closest approach in October, closer to Mars than to Earth at that time. That gives spacecraft like MAVEN, Mars Reconnaissance Orbiter, and even the distant JUICE mission a chance to get a close-up look. Here's something even more remarkable. We're seeing 3I/Atlas while it's still far from the Sun, and it's already showing signs of activity. As it nears the Sun, it'll heat up, brighten, and likely sprout a tail as its ices vaporize. Earth won't be close, but Mars will, giving us a rare opportunity to study an interstellar visitor up close. But here's an unfortunate limitation. When 3I/Atlas is at its brightest and most active in October, the Sun will block our view from Earth. We'll have to wait until November for another glimpse, unless, of course, spacecraft near Mars or orbiting Jupiter can capture the show. So what makes 3I/Atlas special? For starters, it's huge, estimated at 10 to 30 kilometers across, dwarfing both 3I/Atlas live. Watch the new Interstellar Comet online. An extraordinary discovery has just shaken the astronomical community. A brand new interstellar visitor named A11PL3Z, now officially designated as 3I/Atlas or C/2025 N1 Atlas. This marks only the 3rd time in history such an object from beyond our solar system has been identified. But here's where it gets particularly fascinating. You can witness this rare cosmic traveler live, online, right from the comfort of your own home. Discovered on July 1, 2025, by the Atlas Survey, this mysterious object quickly received its formal title 3I/Atlas, just a day later. To put this into perspective, only 2 other interstellar bodies have ever been detected passing through our solar neighborhood. The famous 1I/Oumuamua in 2017, which sparked intense debate about its origin and nature, and 2I/Borisov in 2019, which was confirmed as a genuine comet from another star system. The orbit of A11PL3Z has been carefully tracked and imaged by experts, including David Rankin from the Catalina Sky Survey, providing valuable insight into its trajectory and characteristics. The incredible news doesn't stop there. The Virtual Telescope Project 2.0 is hosting a live online viewing event on July 3, 2025, starting at 2200 hours Universal Time Coordinated. This means you can observe 3I/Atlas in real time through high-powered telescopes streamed directly to your screen. No need for specialized equipment or traveling to remote observatories. Simply tune in online to catch this cosmic visitor in action. To join this extraordinary event, just visit the Virtual Telescope Project's web TV page at the scheduled time. https://www.virtualtelescope.eu/webtv/. This user-friendly platform makes it easy for astronomy enthusiasts of all levels to experience the wonder of space firsthand. If you'd like to delve deeper into upcoming astronomical events or learn more about the project, feel free to browse their schedules and announcements at https://www.virtualtelescope.eu/upcoming-events/. And while you wait to join the event, you can click here to be taken straight to the live stream. https://www.virtualtelescope.eu/webtv/. No waiting, no hassle. Supporting the Virtual Telescope Project is another way to stay connected and help this incredible public science effort continue. By donating, you gain exclusive access to stunning images like the magnificent Comet C/2023 A3 Sagittarius, along with other unique content prepared especially for supporters. Every contribution helps keep the skies open for everyone to explore. Now, here's a question to ponder. What does the discovery of 3I/Atlas imply about the frequency and diversity of interstellar objects visiting our solar system? Could there be many more waiting to be found? Or are these rare cosmic visitors truly exceptional? Share your thoughts and join the conversation below. Your perspective might just shed new light on this captivating topic.